Hello YouTube, this is Dazza the cameraman. Today is Sunday, March 20th, 2016, and today is the March equinox, which means that the sun rises due east and it sets due west, regardless of your latitude. This is a flat earth simulation of the sun's rotation around the disk of the flat earth. As you can see, we've also got the moon chasing the sun, the permanent 180 degrees from the sun. Apparently that's about as high tech as a flat earth simulation gets. But anyway, I digress. So today was the equinox, which means that the sun rises due east and sets due west. The red circle on this flat earth approved map represents the path of the sun at the equinox, which is March and September. Here is a standard Earth map showing the path of the sun at equinox along the equator at 0 degrees latitude. And here we see the time of sunrise and sunset as seen from my location here in New Zealand. We had sunrise at 7:18 AM and sunset at 7:27 PM. Here is the position of the sun at sunrise as seen from New Zealand. You can see that we're just on the edge of sunrise here with a shade. And here is the position of the sun at sunset. Again, here you can see that the shade is just on the edge of the central North Island. So now we need to translate this information back to the official flat earth map to see how it looks. Again, the orange circle represents the path of the sun during the equinox in March and September. As you can see, I've marked the positions of the sunrise and the sunset as seen from New Zealand. But remember that on the equinox the sun rises due east and sets due west. So I've drawn this orange line to show due east and due west as seen from my location here in New Zealand. You'll notice that the position of sunrise and the position of sunset is nowhere near this east-west line. When we draw green lines from my position to the actual position of sunrise on the left and the actual position of sunset on the right, as shown on the official flat earth map, we see that there is an angle difference of 55 degrees between due east, due west and the actual position shown on the flat earth map. This is clearly not what we see in the real world. At equinox, the sun rises due east regardless of your latitude. Now I'll just make this really simple for the flat earthers because they tend to have a lot of trouble following simple details. What I'm saying here is that at the equinox, the sun rises due east, so I should be looking in this direction, not looking in this direction. And when the sun sets at equinox, I should be looking due west, not in this direction. When we look at the flat Earth map, we see that there is a 55-degree difference between what we should see and what we actually see. Clearly, the flat Earth model does not work in practice. It never has, it never can, and it never will. The equinox sun cannot work on a flat Earth model. It is debunked.